Welcome to the 2025 Space Sustainability Research Fellows Report webinar. My name is Kathleen Brett, and I am a program analyst at Secure World Foundation, often referred to as SWF, where I focus primarily on the intersection of outer space security and sustainability. SWF promotes secure, sustainable, and peaceful uses of outer space in ways that contribute to global stability and deliver tangible benefits here on Earth. Our mission is to work with governments, industry, international organizations, and civil society to develop and promote ideas and actions that advance space security, sustainability, and the peaceful use of outer space for the benefit of all. As a part of this mission, we recognize that many of the underlying rationales and foundational concepts of space sustainability are often forgotten, misunderstood, or oversimplified. As a result, the basic concepts, facts, and rationales that underpin space sustainability require continued investigation, discussion, promotion, and broader socialization across the space community and beyond. One of the ways SWF advances this effort is through our Space Sustainability Research Fellowship Program. Each year, our research fellows are tasked with investigating and answering questions related to one or more fundamental concepts that underpin space sustainability. Fellows complete a substantial original research project culminating in a final report of publishable professional quality. The fellows' products are shared publicly through the SWF website and help inform policy discussions, industry practices, and future research. In 2025, our fellowship program focused specifically on two topics: the circular space economy and improved information sharing for space sustainability. Both of these topics are critical to shaping how we manage and protect the space environment moving forward. Today's webinar is part of a broader effort to elevate understanding, foster dialogue, and support informed action in the pursuit of secure, sustainable, and peaceful space domain. Thank you for joining us today. Before we begin, a brief note on today's structure. Fellows will have approximately 25 minutes to present their research and key findings. Following each presentation, we'll hold a brief moderated question and answer session to allow for discussion and audience engagement. Our moderated portion of the webinar will be led by Dr. Peter Martinez, the Executive Director of SWF. Dr. Martinez has extensive experience in multilateral space diplomacy, space policy formulation, and space regulation. He also has additional experience in capacity building in space science and technology. Please feel free to submit questions during the fellows' presentations, and we'll do our best to address them in the given time frame. Additionally, a closed caption version of our webinar will be available on our YouTube channel. Thank you. Now to introduce our first fellow presenting. Callum Turner is a clean space systems engineer working for Telespazio and ESA's Clean Space Office. His work includes understanding pathways towards circular space economy. A graduate of Viseu Suparo in the University of Edinburgh, he holds a master's degree in aerospace engineering and astrophysics. Additionally, Dr. Barul Sadi Turnbull is a postdoctoral research associate at Durham University, specializing in space sustainability and circular economy strategies. She holds a PhD in mechanical engineering from the University of Leeds, where she was a Marie Curie Research Fellow and received both a BSc and MSc in materials engineering from Istanbul Technical University. A holder of a European patent for innovations in polymer recycling, her research now focuses on developing reuse, recycle, and repair approaches for in-orbit assets to enable a sustainable space economy. The title of their report is Exploring the Circular Economy in Space. While Baril is not able to join us today, we would like to acknowledge her hard work on this project. Callum, please begin.
Perfect, thank you. So hello, everyone. As mentioned, I'm presenting on behalf of myself and Baril, but unfortunately only I can make it today. So just bear in mind through the presentation that there's both of us contributed to this report. So next slide, please. So we've just heard our bios, so I won't go through these again, but there is one caveat I'd like to make clear before we get started. So the opinions in this presentation are all based on information in the public domain, and I've got to say from my side that the views are not necessarily those of ESA or any of the organizations with which we work. So just wanted to get that out of the way, and now I think we can get started with the next slide, please. So we're going to have a little bit of a whistle-stop tour today of some of the work we're doing and looking at the circular economy. So we'll look at what a circular economy is, how this narrative has come to be, what it looks like in space, some of the technologies you need to enable it, and then a couple of case studies. And we'll have time to have a little bit of an examination of how you might create the circular economy in space, and then look at the key takeaways from our report. And fundamentally, we'll ask, is there a case for a circular economy in space? So that's the plan, and I think we can get started. The next slide, please. So, yeah, what is a circular economy? So it's a fundamental question we need to get out of the way at the start of the webinar. So next slide, please. It's a little bit challenging to define a circular economy in space. So some researchers in 2017 did quite a broad analysis of the different definitions of a circular economy, and they found there were 114. When they returned to this task in 2023, they swelled into 221 definitions. There's quite a lot of discussion of this in the literature on the circular economy. It's been noted it's almost easier to say what it isn't than what it is. But thankfully, this is coalesced to a certain extent through ISO 59004, which is a standard on the vocabulary and terms for a circular economy. So, roughly, a circular economy is an economic system that uses a systemic approach to maintain a circular flow of resources by recovering, retaining, or adding to their value or contributing to sustainable development. So, a lot of words there. In maybe a more tangible way of looking at this is it's a way of making resources stay in circulation. So on the right of this slide, you can see there's two different models. Broadly speaking, we've mostly followed a linear model in industrial economies. So you extract raw resources, you make something, you use it, and then you dispose of it. It's a very end-to-end process. The idea with a circular economy is to try and make more loops for resources. So you reuse products, you can share them, there's servitization of products, there's lots of different strategies, but the key idea is to kind of keep resources in circulation and decouple economic activity from resource extraction. So that's kind of the core concept of a circular economy. And next slide, please. So, a broad overview of what it is, and now kind of what does it look like? You'll probably have heard of the 3 Rs. These are circularity strategies. They're often called Rs. That's because they all start in Rs, like just the way the verbs work out. So we have refuse, rethink, reduce, etc. You'll probably be familiar with reduce, reuse, and recycle. But this can be spread out into a sort of more nuanced list of up to 10 of these different circularity strategies. One of the key things to note about these are hierarchical, right? Some of these are kind of preferable to others in terms of circularity. So if you look at the diagram on the right here, the most, I suppose, the easiest way of reducing resource consumption is just to refuse to use new products. Often that's the most difficult to actually implement, right? There's a lot of vested interests. There's a lot of reasons you might want to have new products, keep using new things. But that's the easiest way to preventing using extra resources. And these go down through the ranks until you end up with things like repurposing and recycling at the end. The reason that recycling is ranked quite lowly here is that you can lose a lot of the embedded value in a product when you recycle it, right? You get the raw materials back, but you lose all the energy, all the effort that was made into making it something useful. So in a circular economy, resources are sort of largely retained using these different circularity strategies. And I think we can go to the next slide, please. So this isn't actually a new idea. To a greater or lesser extent, people have been doing this for thousands of years. So we've got good evidence from the Stone Age, from ancient Rome, of reusing various resources when resources were scarce. So in the Stone Age, you've got these various stone tools. In ancient Rome, there was a reuse of architectural elements. I think this process was called spulia, so using different parts of architectural, I suppose, decoration and integrating these into new and later designs. As an aside, it's not entirely clear if this was due to resource scarcity or trying to take some of the, I suppose, the grandeur of previous architecture and putting it into new ones. Another example we came across in our research is from Edo, Japan, where there was lots of strong resource reuse and circulation inside the Japanese economy. The reason for this, it was very closed off at the time. It was very isolated from the rest of the world. So there was no real route for new raw resources to enter the economy. And so there was a lot of circulation and different ways of retaining value. So that's a little of historical context. We've covered kind of what a circular economy is, what it looks like. Now we can move on to having a little look at what this would look like in space. So we have the next slide, please. So one more again, please. Great. So we started out by trying to have a working definition of what a circular economy in space would look like. So to start with, we kind of combined ISO 59000 family and the UN COP/US long-term sustainability guidelines. I won't read this out verbatim because I'll just skip right to the revised definition. But as I'll explain later on the webinar, we talked to a lot of experts in the course of our research, and we got their insights into how we could revise the definition to try and capture all the relevant aspects for a circular economy in space. So our working definition is that a circular economy in space is one in which space systems are designed and operated in a manner that enables these systems and their subsystems, components, materials to remain in use through an ecosystem of space-based servicing and manufacturing techniques. So it seeks to minimize waste, optimize research use, and preserve the space environment for future generations, all while supporting the long-term sustainability of space activities in all its aspects. So to be clear, this is not just environmental sustainability in space, but also economic and indeed the other dimensions of sustainability. So could we go to the next slide, please? Right, so I'll do my best to present Bro's research here, but forgive me if there's anything's not clear, because this wasn't the section of the report that I worked on. So we had a look at some of the other sectors that have sort of enthusiastically taken on circularity to a greater or lesser extent. And one of the ones that was most interesting was looking at marine debris as opposed to space debris, because there's a lot of commonalities between these two worlds. In terms of the actual material degradation, there are analogous processes, right? So for marine debris, this is predominantly looking at ghost nets or cast-off fishing nets in the ocean. There's lots of fragmentation patterns. So there's abrasion, there's thermal and chemical erosion. Similar, analogous processes will happen to space debris. There's an overall cumulative trend from the 1960s, both for marine debris and for space debris. And there's also challenges of ownership and management. So both the high seas and space are, in a sense, international waters, right? So there's kind of murky questions about ownership and responsibility. So some of the interesting ideas that were proposed by Napper et al. In translating policies on marine debris to space debris were to try and implement extended producer responsibility, make people more accountable for what happens to their systems after use, and then developing and enforcing international legislation, again, this idea of accountability, and then incentivize innovation and debris mitigation, so try and make it worth people's while not to create so much space debris. And then finally, there's the idea of fostering science-based cooperation. So, next slide, please. All right, so where are we starting from in the space sector? So we'll go through some of these circularity strategies and see to what extent they've already been put in place. I talked earlier about refuse, right? So if you refuse to use new systems, new products, you prevent a lot of resource use. However, it's not easy to implement, right? There's lots of vested interests. There's lots of duplication for quite reasonable reasons. So you can think of an example of GNSS systems, so satellite navigation. For reasons of geopolitical rivalry, for various military interests, you will always have a duplication of these systems. Some of the other circularity strategies here, we have rethink and reduce. So rethinking how we use systems in space has already started to happen. So a good example is servitization. So hosting, for example, payloads as a service. So a platform, and you can plug and play different payloads before launch instead of the traditional monolithic architecture towards a mission. I think in the interest of time, I'll move on to the next slide, please, because there's a lot to go through here. Okay, right, reuse is an interesting example. Maybe the most salient example of reuse in the space sector is, of course, the reusable boosters from SpaceX. So this is one of our case studies that I'll talk about in a little bit more detail later. But it's interesting to note that it's had a sort of profound impact on the launcher ecosystem. In terms of repair, there's long experience of maintaining the ISS, but it's maybe less mature in terms of robotic servicing of satellites. And then refurbishing, one of my favorite examples is the refurbishment of the Hubble Space Telescope. My background's in astronomy, so I'm always keen to talk about this, and I'll talk about that later on. And then the next slide, please. So finally, looking at remanufacture, repurposing, and recycling. These are less mature, I think, in the space sector. There have been some pilot studies, some examples, particularly of recycling plastic on the ISS. But in terms of full spacecraft, there are a lot of technical challenges to be solved before we can achieve this in orbit. So next slide, please. All right. So we've talked about what a circular economy is, what this might look like in space, and what we can learn from other sectors. And now I want to spend a little bit of time talking about the technologies that let us do this. And this is fundamentally in-space servicing, assembly, and manufacturing. So we can go to the next slide, please. So in a nutshell, ISAM, in-space servicing, assembly, and manufacturing, is a broad suite of missions and technologies that let you service assets in space. So this can be repair, refurbishment, refueling, inspection. There's a wide variety of mission concepts here. For something more concrete, you can look at MEV1. This is the Mission Extension Vehicle 1. This is an AOCS takeover. That's the Attitude and Orbital Control System. So it basically takes over control of a satellite in geostationary orbit. The reason that you might want to do this is that geosatellites are very profitable, but they need to consume propellant to stay on station, to stay in their allocated slot in geo. If they run out of propellant, ideally before they run out of propellant, they need to be removed to the graveyard orbit, and you can no longer run them as an operational system. In the case of MEV1, the mission concept is to plug onto the back of the GEO spacecraft and keep it in its allocated place in orbit. So you can keep on running it for longer, it remains a profitable system, and you have this mission extension. So it's not the only mission, there's also MEV2, and here in Europe, there's the upcoming RISE mission that will do something similar. So this is a tangible example of what ISAM looks like in practice, or at least part of ISAM. But as I mentioned, it's a very wide range of technologies and missions. If you're interested, I can happily recommend NASA's ISAM State of Play report, which is an exhaustive look at the technologies, missions, and providers in this sort of the ISAM world. So onto the next slide, please. There's a lot of different technologies that kind of make up what's key for ISAM. I won't go through the right-hand side of this slide because it's in very small text, but broadly, we can look at 5 categories here. So advanced robotics. A lot of the historical ISAM missions, I suppose, so things like assembling the ISS, refurbishing Hubble, were done with astronauts, but it's expensive, it's risky, and increasingly it's not really viable. We don't have the infrastructure to do these surfacing missions beyond the ISS. So in its place, you'll need advanced robotics, and there's a lot of different technologies under that broad heading. Things like modeling the dynamics, looking at machine vision. There's a lot of work that needs to be done on advancing our state of space robotics. In terms of verification and validation, if you assemble a system on orbit, if you refurbish it, if you refuel it, you need to be pretty sure that what you've done was effective, that it's still working as expected and the mission was carried out as you wanted it to be done. And so, particularly in the future of ISAM, if you're thinking of something like assembly of a large system, the example I like to think of is assembling a large telescope, a large astronomical observatory in space. You'd have to have some way of verifying and validating that you put it together right. Particularly if you're doing this autonomously, which is potentially a future use case. You'll need this sort of suite of technologies to check out what you've built in orbit. In terms of modular spacecraft and standard interfaces, this is kind of a precursor to having more serviceable spacecraft. So if you can sort of plug and play different modules, say in the case of Sentinel-1B, an ESA spacecraft is a good example. There was a space debris impact on one of the solar arrays, and it punched a hole straight through it. It was still operational, but say you wanted to return it to full operational capacity. If you had a modular spacecraft where you could remove the entire solar array and its drive motor with a different module and put it back in place, you have a lot of operational flexibility from that architecture. There's a lot of different things you need to look at for modular spacecraft, particularly interfaces, so you can have these standardized chunks that go together. But a lot of this work was already done in past missions. So it's an interesting field to be looking into. In terms of manufacturing processes, if you're going to do things like assembling systems in orbit, then you need to have the technologies to put them together. So some examples are additive manufacturing on the ISS, but there's also looking at forming and welding in orbit. And then finally, it's RPO, so rendezvous and proximity operations. If you want to do this, you need to get systems in space close to one another. You need to do it safely. So you need a variety of different technologies to do this, from the sensors on board servicing spacecraft towards the adaptations you make to a client spacecraft to make it easier to rendezvous with, to grasp, and to service. So there's a broad suite of technologies there, but those are kind of the 5 overarching categories. All right, I think that winds up me talking about technologies, and we can go on to looking at some of these case studies. So these are 2 examples of space circularity in practice. As I promised, I'll talk about Hubble first. So the Hubble Space Telescope was designed with maintenance in mind. So there were 5 servicing missions in total launched to Hubble, and some of the maintenance they carried out was planned, and some of it was improvised or unplanned. They obviously made very detailed mission plans, but these weren't originally envisaged in the design of Hubble. The main reason for this was a spherical aberration on Hubble's primary mirror. This led a lot of their science goals to be unattainable. But because Hubble had been designed for servicing, it was relatively easy to install adaptive optics, to have instruments swapped out over the course of the spacecraft's life. In fact, the solar arrays were replaced as well. Where I'm sitting in ESTEC has some of Hubble's original solar array that flew in orbit up on the wall. So there was various parts of this telescope were swapped out and improved over its lifetime. And as a result, it's remained very productive as an observatory. Even until now, it's one of our foremost space observatories. And I suppose the key takeaway we've taken from this case study is that if you design your systems to be serviceable, if you have an ecosystem of servicing spacecraft or capabilities in place, then you have a lot of operational flexibility, particularly in the face of the unexpected. The other case study we looked at on the next slide were reusable launches. And there is an interesting duality to the circularity of reusable launches. So for a little bit of context, SpaceX dominated the launch market. In 2024, the last year we could find data, they launched 52% of successful orbital launches, which is a huge share of the market. Part of the reason they're able to do this is because they're relatively cheap. They can reuse their launches, and that, coupled with economies of scale, mean that you don't have as high a cost per kilogram to get things to orbit, and as such, you can launch a lot more stuff. A lot more people are inclined to launch with you. It's a very high-level explanation, but that's kind of the context here. Now, while this is an interesting, I suppose, economic benefit to a circularity strategy, in this case reuse, it's had the knock-on effect of making it a lot cheaper to launch to LEO. And there's been a vast increase in the number of satellites, particularly due to mega constellations in LEO. And these aren't designed for circularity. They're disposable satellites. They're launched, they operate, and then they burn up in the atmosphere. So there's been an interesting interaction between a circularity strategy that's led to a quite non-circular outcome. So next slide, please. All right. So we've had a little bit of a talk about what the circular economy is, looked at it in detail in the space sector through a couple of case studies. And now we move on to the final stage of our report, where we talked to some experts and asked how we might want to create this. What might the benefits be of the circular economy in space? So we talked to 14 different experts. You can see some of the institutions listed on the right of the screen here. And they had a wide variety of backgrounds. So some from academia, some from industry, some from space agencies, and a wide variety in expertise. So as well as engineers who are experts in policy and law, specifically in recycling. So we had quite a broad overview of the circular economy as a topic. And next slide, please. So one of the key things we talked about, and the thing I'll talk about here, is why would you want to do this? What's the benefits of a circular approach to space activities? There were three broad categories we looked at here. So environmental, economic, and operational. I'll start from the bottom up, since the operational one ties in nicely to the case studies we're talking about. So if you have a more circular approach to your activities in space, if you have, for example, modular spacecraft, if you have an ecosystem of servicing techniques available, then you have a lot of operational flexibility. As I mentioned, if something breaks, it can be repaired. If you run out of fuel, you can be refueled. You can get a lot of life out of your asset that wouldn't necessarily be possible if you had a traditional non-circular approach, I suppose. In terms of economic benefits, there was broad agreement amongst our interviewees that there is an economic rationale for a circular economy in space, but the business cases aren't immediately clear in the short term. So I suppose a good example of this would maybe be the MEV missions that I mentioned earlier. So 2 of these have flown, but it's not led to that widespread an adoption in geostationary orbit. So for context, there's around about 570 satellites operating in geo, and only 2 of them are having their lives extended by the MEVs. There'll be 1 in a couple of years as RISE launches, but still it's a low proportion overall. So the business cases were seen to exist by our experts, but the timeline at which they become viable wasn't very clear. And then finally, the benefit would be environmental. So this is kind of what underpins the concept of a circular economy more broadly outside the space sector, and it's equally true in the space sector itself. So if you have a reuse of resources in orbit, you can have reduced launch numbers. That's good because every launch is associated with quite a lot of resource use, quite a lot of emissions. If you can minimize that, then you've moved towards having a less of an effect on the environment. Also, reusing materials in space means you have less leftover trash in space, less space to be, right? If you can reuse those resources, you reduce the risk overall. It's easier to operate systems in space. Okay, so I see I've got 5 minutes left. So I think if we can move to the next slide. Perfect. So according to our interviews, what does the outlook look like? What are the biggest interventions that our experts expect to see in the space sector that will move us towards a circular economy? So they mentioned in-orbit servicing. That's another way of referring to ISAM, and particularly life extension. So this is the kind of missions I was talking about with the MEV-1 and 2 and with RISE. More broadly, there's quite a lot of interest on refueling missions. There's missions being studied for repair and modular replacement. So they saw in-orbit servicing as taking off and sort of moving us towards circularity. In terms of serviceability, there was the interest in design and standardization. If you have standardized interconnects between different spacecraft components, then you move towards this more modular system. And then finally, there was an expectation of enablers from government, or kind of how you can incentivize this from the point of view of agencies of government, in particular looking at interoperability, trying to clarify some of the regulatory landscape around these activities. So if I could go to the final slide, I think the final couple of slides. Yeah, here we are. So this is a good way of summing up the overall tone, I suppose, of our interviewees, which is we'll probably never make it perfect. People aren't perfect, but it doesn't need to be. We just need a good enough version that's better than today. So let's go on to our conclusions then. Next slide, please. So I should comment that we were originally planning to present one side of the argument each, Beryl and I, but now I'm in the strange position of arguing with myself about the circular economy in space, but I'll do my best. So the case for a circular economy in space. There is an argument to be made that it helps the sustained use of outer space for future generations in line with the COPUOS long-term sustainability guidelines. There is an improved efficiency of spacecraft, improved operational flexibility, as we've discussed, and then the idea of new business models and environmental benefits to the space sector. On the other hand, this is also quite an expensive undertaking, right? It's costly to redesign systems to be modular, to be serviceable. The business cases are uncertain, as I mentioned, and generally speaking, if something works in the space sector, we're not keen to replace it. So there's a certain risk-averse culture that would maybe hinder adoption of a circular economy in space. Also, space is hard. Trying to carry out circular activities on ground is difficult enough. Doing it in orbit, much more challenging. As I mentioned earlier, launch prices are falling. It's becoming easier to have single-use disposable satellites. And then, as is commonly said, space is contested and congested, right? So there's a lack of coordination and competition between space actors, and that works against enabling a circular economy in space, which needs to be done in cooperation, or at least on interoperability. However, on balance, between the arguments for and the arguments against, we're cautiously optimistic. So we think circularity is achievable, but only if policy, markets, and technology co-evolve. So I think I've got 2 last slides we will go through quickly. Next slide, please. So this is just a bit of promotion. Please read the report. So we only covered a small amount of what we have in the report in our presentation today. If you're short on time, we've tried to condense everything down into 15 bullet points, 15 key takeaways from the report, and then you should know more or less what we want you to take away from this report. We've also got some more case studies, and as we mentioned, there's a much more full treatment of the expert interviews we did. And with that, I think I'll leave you on the last slide, which is a link to the report, and I'll be happy to take any of your questions. Thank you.
Thank you so much, Callum, for your thorough presentation. Now we will transition to our question and answer session moderated by Dr. Peter Martinez. Please continue to submit your questions in the chat. Dr. Martinez, please begin.
Thank you, Kathleen, and thanks, Callum, for your excellent presentation and your very interesting report, which I enjoyed reading, and I'm glad to see that we have some questions coming in the chat.
So I think the moderator is joining, but in the interim, oh, there you are. I'll leave it.
You can hear us? You can hear us?
I can indeed.
Great. Yeah. So let's just dive right into the questions then. I noticed that you spoke about the key technologies for in-space servicing, assembly, and manufacturing. What would you say are the other key technology enablers for circularity over the next 5 to 10 years?
It's an interesting question. I think the key technologies are definitely ISAM, as I mentioned, but there's a lot of other technologies that you'll need in place. So I think one of the aspects we found really interesting is kind of the traceability of what's in orbit, right? Because the circular economy is really like linking up resource flows. So at the end of something's life, products or a system's life, it can be reused in another setting. So having some almost digital passport, if you will, to follow space systems through their life, to have some kind of health monitoring, so you know what the condition, the location, and the kind of the possible use cases of different components of modular spacecraft could be a useful technology that would be developed were this to become a reality. And I think within that broad category, you could look at little subdivisions, so things like health monitoring, as I say. I think digital twins is an emerging way you might want to look at this. So I think that's another big aspect of the technological needs for a circular economy in space.
Thank you. Switching over to one of the audience questions, and this is one that I was interested in myself. Where would you say the circularity business case is currently strongest? LEO versus GEO, or commercial versus institutional?
All right, yeah, no, that's a really interesting question. I would say that the case is probably strongest in GEO. The individual spacecraft are of higher value there, and you can probably make a stronger business case as it stands for extending their lifetimes, because they once they're in orbit, they're often remain profitable, and then the limiting factor is the propellant on board. In LEO, it's a little bit harder to make the argument for circularity strategies at present. In terms of governmental versus institutional, institutional versus commercial, I would say it probably needs to be a little bit of a combination. So the MEV-1 and 2 missions are primarily commercial. RISE, the upcoming mission extension mission, is something of a mix. So part of it is an institutional mission, and then part of it goes on to do commercial servicing. More generally, I think the way I see the most viable model of this is institutional missions kind of paving the way, de-risking technologies, building out some of the infrastructure we need, and then creating the framework for commercial missions to take place. So I don't think it's going to be one or the other, but more a combination.
Thank you. We have another question from our audience. You're asking, does the circular strategy also cover existing orbiting?
Yeah, a very interesting question. In an ideal case, yes, right? So there's been a couple of studies that have looked at the possibility of recycling space debris, particularly some of the most concerning pieces of space debris. I think there's a paper that ranks the 50 most concerning pieces of space debris, and a lot of them are old upper stages, which are predominantly aluminium, and they're quite easy to recycle as a result. The main strategy looking at space debris is recycling. So the idea is you can pull apart derelict satellites, cast off upper stages, and reuse the material to make something else. However, it's ferociously complicated, right? So recycling on ground is quite tricky. Doing it in a zero-G environment where you have to capture space debris, bring it in, contain all the fragments, you have to do things like shredding the debris, deconstructing these spacecraft, sorting out the different materials. If you think of a spacecraft, removing like the electrical harness is a huge job in and of itself. So doing that robotically in orbit is challenging. However, indeed, it has been studied and could be feasible in the future, but in the short term, I think it's still very technically challenging to put in place.
Thank you. Thank you. So turning to the R strategies that you described, you presented 2 examples of the implementation of some of the R strategies in space. You spoke about the Hubble telescope and the reusability of the SpaceX launchers. Is that kind of the extent of where we are now with implementing these R strategies in space? How circular is the space sector at present?
Okay, thank you. It's another interesting question. Not very, I think, is the honest answer. So as I mentioned, in terms of mission extension in GEO, there's only a handful of satellites that are going for this option. The vast majority will just be left to meander through the graveyard orbit at the end of their mission. Some of the other strategies have been piloted on the ISS. So additive manufacturing has been used to recycle plastic feedstock, I think. But in general, I think they're very preliminary, a lot of these strategies. There are a handful of examples, but by and large, I think the space sector lags behind sectors here on ground in terms of circularity.
Thank you. So we have another audience question, which I will paraphrase as, did you in your work, did you consider the effect of dominant space actors and the anti-competitive effects of a dominant space actor on space circularity principles?
It's an interesting question. I'd have to give it a little bit of thought. It's not something we encountered in our research. But as a first answer, I think I would say that the functioning circular systems on Earth tend to have a diversity of actors and lots of interactions between them. So having one dominant actor is, this is a very preliminary analysis off the top of my head to caveat, I can't imagine would be that conducive towards circularity. In particular, I think there's dominant actors' wishes or strategies would probably end up dominating the ecosystem overall. So it's maybe not the surest route towards implementing a circular economy in space.
Okay, well, kind of keeping on that track in terms of the systemic levers that can be used. What would you say are the policy or procurement levers that could most effectively accelerate adoption of circular economy principles? Things like standards, incentives, data sharing requirements, etc.
I think one of the easy fixes to build out this ecosystem, and this is from my perspective as an engineer, is standardization and preparing systems to be serviced, right? Like there's lots of relatively simple changes you can make on a system level to make spacecraft more suited to circular operations. So if you add a grapple fixture so they can be to enable rendezvous and docking, if you can have rendezvous aids to make it easier to find these things in space and carry out RPO, rendezvous and proximity operations with them, that's going to make a difference. In terms of regulations and incentives, I think one of the things that came through in our report is there's quite a lot of regulatory uncertainty. So just having clarity about what can be done and what can't be done, and then once that regulatory landscape is a little bit clearer, incentivizing more circular actions through things like, maybe tying insurance to circularity or the end-of-life strategy you choose for your system could start to move things gently in that direction. But I think sort of standardization and clarity is the simplest way forwards.
Okay. We have another audience question. Could servicing missions, while potentially reducing certain operations and maneuvers such as collision avoidance, actually require additional spacecraft movements from one orbit to another, thereby increasing orbital overall maneuvers and creating more orbital traffic?
Yeah, another interesting question. Thank you. So I suppose this becomes a question more of space traffic management and space situation awareness more than circularity. But yeah, indeed, it's not like ISAM missions are risk-free and won't have an impact on the space environment overall. So it's something that needs to be carried out carefully. More broadly, I think one of the key takeaways we found in our report is that circularity is not really a cure-all in terms of space sustainability, and there needs to be a case-by-case evaluation of whether or not it's a good idea to implement these strategies. And indeed, for the case of ISO emissions, considering their effect on the space environment overall from the point of view of space traffic management would be part of this trade-off, part of the careful analysis you'd want to do before embarking on this mission.
Thank you. Yes, it's a good point how, we're trying to find the balance where activities to implement circularity principles can themselves lead to non-circular outcomes, right? So finding the balance is the interesting part. Okay, we are running close to time, but I want to squeeze in one more question. This is kind of in your report, towards the end of your report, you mentioned the various actors and roles of actors, and you touch on space agencies, commercial operators in the space industry, and mention how they each have distinct roles to play in realizing circular space economy principles. So what would be your message to the head of a space agency or the CEO of a commercial space enterprise? What would you want them to know about the circular space economy, and why should they take note of this concept?
So I think for both of them, I want them to know that there are benefits to having a circular economy in space, and these can be economic, these can be operational, and it gives a lot of flexibility to how you design and carry out missions. So in both cases, that I'd want them to appreciate that this is a suite of technologies and strategies that can give us access to new ways of carrying out missions in space, new ways of managing the space environment. And it's a tremendously powerful set of tools that we could use to make sure that we use space sustainably. Specifically for the head of a space agency, I'd want to encourage them to make small changes to their missions that would make them more serviceable. So just future-proofing designs by things like I mentioned earlier, preparing missions for rendezvous and proximity operations, for preparing them for docking is a relatively minor system impact. It can make a big difference once this ecosystem of servicing technologies becomes more apparent. For a CEO, I'd say that you can look at some of the other space actors and see where you can build ways of working together. So take the example of say you make fantastic payloads. That's your main bread and butter. There's already options to have the servitization of platforms, so you can have a sort of a plug and play platform with various different payloads on it. Maybe you find a way to reuse these payloads at the end of your mission. So maybe somebody else will pay to take over that payload once you've finished. And once you start to build these connections, you kind of build up this web, this ecosystem of reusing resources in orbit. And that's kind of the essence of what a circular economy in space would look like.
Thank you. Well, I see that our time has caught up with us, and we want to move on to the second presentation and discussion for this webinar. So, Callum, thank you very much for your presentation, and congratulations to yourself and Biril for this excellent work. And I would really encourage all of the participants in the webinar to download the report and read through it, because there's a lot more detail there than we were able to cover in this short presentation, but we hope it has whetted your appetite to view the full report. So with that, thanks again, and back to you, Kathleen.
Thank you so much, Callum and Dr. Martinez. I'd now like to introduce our next fellow. Deborah Housen-Coriel is an expert legal practitioner, consultant, and researcher in the fields of outer space law, cybersecurity, and data privacy. She was a core expert in the drafting of the Manual on International Law applicable to military uses of outer space, and is a member of the editorial board of the Encyclopedia of International Space Law at McGill University. She also served as a core expert in the Talon 2.0 Manual on the International Law applicable to cyber operations. Deborah teaches international space law at the law faculty of Hebrew University, where she is on the advisory board of Cybersecurity Research Center and Information Policy Regulation at Reichman University's Data, Government, and Democracy program. She is the founder and principal of Housen-Coriel Law Offices, a practice focusing on tailored compliance solutions for clients in Israel and internationally. Her most recent areas of academic research include best practices for information sharing between the private and public sectors. Her report is titled Information Sharing to Promote the Sustainability of Outer Space Activity Towards Development of Model Agreement. Please begin, Deborah.
Thank you so much. I'll share my screen. Here we go. Let me know that we're good to go.
Yes, we look good.
Great. So hello, everybody. I'd like to start out with thanking the SWF team for hosting this webinar and also for supporting the fellowship program, which is a really wonderful and a wonderful research opportunity, and I'm grateful for that. So we're going to talk today about information sharing for space sustainability, and we first need to figure out what the problem is. So the problem is, like many of our contemporary problems, has several aspects. And the first one that I'd like to share is that we're really looking at a collective action problem, which focuses in on how to reduce risk for space activities overall so that they continue to develop sustainably and that they continue to embody discovery and innovation as well. As we all know, this is a space expert audience. Space is inherently harsh and risk heavy. It's really difficult to control space objects, both physically and virtually, and from Earth and from space as well. We also have a critical dependence on cyber capabilities. In the meantime, we don't have hardware that heads up into outer space. Maybe we'll hit that in the future. But cyber capabilities have their own sets of risks that need to be factored into space activity risk. With the increasing commercialization and militarization of outer space, which are really the two big influences that we're feeling in contemporary times, intentional and hostile threats are increasing, and they may be commercial threats, they may be national security threats. Both are relevant to outer space sustainability protections. And finally, near Earth space will become more and more crowded with space objects and debris, and Colin discussed that in the earlier presentation as well. This is sort of a beginner's Space 101 slide, just to get us in the mode of thinking about growing challenges of outer space activities. Everyone present can think of more of additional challenges, but to just get us thinking of how diverse space activities are and how they really push us at the present time to get, as operators, as scholars, as observers, to get an optimal understanding of the outer space environment. And this slide, which one of the first figures in the report that you'll see, it really presents in a nutshell, a triangular nutshell, if you will, what information sharing as a mechanism to minimize risk does when it's done effectively. And we're going to talk in the coming minutes about what that effectiveness really is. So at the center of this pyramid, of this triangle, is trusted information, which is really the outcome that we want for the users of information platforms, information sharing platforms. And at the top of the triangle, we have an improved situational awareness. And I'm immediately going to say we're not talking about necessarily military situational awareness, but a much more all-encompassing one. At the bottom left, a common effort and commitment to sustainability. And I would even argue, and have argued in the report as well, that committing to the information sharing platforms that we're going to take a look at is actually the first step in building that trusted information exchange, because it represents a willingness on the part of information sharers to participate in this process. And then finally, on the right, coordination of space actors to reduce duplication of expert efforts and investments. And the end goal is to mitigate risks in space activity. So this is really sort of a focused look at what we're aiming at when we build information exchange structures for outer space sustainability. Now, this is the takeaway slide. So if you finish this slide and you say, okay, I've got all the bottom lines, you can go have your cup of tea. But I'd like to cover 3 topics. I also really hope you'll stay. 3 topics that I want to focus on in the next few minutes. So first of all, we'll define information sharing for space activities and why it's critical for outer space systems. As we'll see, we're really focused in this report on real-time and actionable information sharing, and we'll talk about what that means. It's got to be short to medium term for operators, and it has to take into account the special characteristics of outer space activities. Secondly, we'll look a little bit at the methodology and current trends. What are the categories of platforms that the report covers? There are 5. What's been the legacy situation up until now, and how did that influence the methodology and the outputs? And then we'll look at some current trends, and we have an example of one platform that we'll take a closer look at. And finally, we'll look at the main findings, conclusions, and a few ways forward, and glance at the principles for a model information sharing agreement that are proposed in the annex to the report. The bottom lines, I'm happy to have your input in questions and comments about all of these and about anything else that comes up in the report, of course, is that information sharing is no longer a best practice. It's long been discussed, not only in the outer space context, in many other contexts as a best practice. Why not share information? But it's really a critical aspect of the feasibility and functionality of space activities from now and into the future. We cannot do without it. Secondly, the information sharing process needs to be carefully managed. We have a legacy of many instances, or several important instances, of information sharing that have been less than optimally managed. That needs to change in order to optimally incentivize and to serve participants. Participants will not use information sharing mechanisms if they're not served by them. We need to think hard about what the critical elements of moving incentivization and operational relevance ahead. Thirdly, given the increasing diversity of space actors, we need to think really deeply about how to incentivize all kinds of types of space actors, the ones we know about today and the ones we'll know about in coming years. I'm not sure whether you can see this from sharing, but the final bottom line is that the scalability of platforms is key. And what we mean by that, as we'll see as we go along in the next few minutes, is that we're really speaking about a system of systems, if you will, of information sharing platforms that can all intercommunicate in real time, if possible. And the direction of the report, the conclusion of the report is certainly not, we need a one-stop shop. That's just not feasible. But it is a strong vote for interoperability of the IS platforms that exist and the ones that are coming into play. So there we have it. There we have everything. We're going to start with defining information sharing for space activities and why it's critical. So the easy start is, one well known to most of us here, is on the left side. So the fundamental example of the IS principle we see in Article 11 of the Outer Space Treaty, familiar to all of us, and it's an easy read, easy on the eyes, and it requires states parties to the treaty, so a large number of states at present, to inform the Secretary General of the UN, as well as the public and the international scientific community to the greatest extent feasible. Notice that it's a feasibility criterion of the nature, contact, locations, and results of such activities. So that's information sharing 101. At the end of Article 11, we also have a requirement for the Secretary General, or more a task of the Secretary General, to disseminate this information. So again, elementary information sharing. It's really interesting, I think, that the OST included Article 11. Even at that early stage of space activities, it was perceived by the drafters of the OST as a really important mechanism. And then we move on from Article 11, of course, to the Registration Convention, which requires the establishment of 2 types of registries, which are, again, means of sharing information: the National Registry and the Secretary General's Registry. So we have in place that sort of underlying norm and principle. In the report on the right side, you just read through it. The working definition is more focused than Article 11. We're talking about a measure that's employed for the exchange of data, which is deemed relevant by the sharing entities, right, which is different from Article 11, in a given domain of activity that's relevant to the resolution of a collective action problem. So first we need to define, according to the report's working definition, what's the problem that we're trying to resolve? What's the collective action problem in any specific information sharing instance? And work backwards from that in order to determine what needs to be shared. sort of a more modern and a more efficient way, in my view, to undertake information sharing. Secondly, the types of information shared need to be predetermined, need to be very specific, and they will develop. So this is it's almost a closed list in Article 11, much more open in the report's definition. And as many of you will know, the current academic and professional literature discusses information sharing in many different contexts, not only the outer space context, as a really important mechanism for building trust among the participants and players in any given ecosystem. They all need to receive added value. So there's obviously more detail in the report about what the definition looks like, but these are the basic elements. What do we mean about the information part? So that seems trivial, not necessarily. We use information in the report to include all the specific terms that will come to mind: data, specs, input, that's used interchangeably. But more importantly, we're really talking, and there's a lot of internal discussion about this with the SWF experts, the focus on actionable information. So there's a plethora of information sharing platforms in outer space, in the whole outer space ecosystem, that are very valuable, but tend to be much more strategic long-term. We focus in the report on actionable data, actionable information sharing, which means you need this information within the next hours, up to 72 hours, or in the short to medium term, a few weeks. We didn't go beyond that. And we'll see a little bit when we get to our specific chart. We'll take a look at what that means. So we're really talking about tactical rather than strategic information sharing. And you can take a look at the types. This is obviously not a closed list. More and more types of information will come into play as the outer space economy develops and more players come in. The challenges to the utilization of information sharing and the incentivization are classic in, I would say, all of the contexts of information sharing, including in the global health sector, in the maritime sector. There are always going to be national security concerns around information sharing in outer space. There are going to be business and commercial considerations for commercial actors. I don't want to share with my competitors, right? There's a risk there. There'll be regulatory restrictions about what one can share, including, if we look at the European context, the private information, private data. The costs of information sharing and the training time. And I really want to emphasize the last one, the reliability of the information platform itself, the information security issue. We all know about instances of the bottoming out of information sharing platforms, even the ones which are the most supposedly secure. Moving on to the methodology and current trends. So the report focuses on five different categories of space activities. The overall space domain awareness, and just to re-emphasize, this term is somewhat invented in order to be sure that we don't stay with the domain awareness that takes us to a military context. We're talking much more generally, overall space domain awareness, which is the highest level of information sharing, or the most comprehensive level of information sharing. Then specifically into the space traffic coordination platforms for sharing, post-mission disposal of objects and debris sharing, lunar activity sharing, which is a really interesting new type of information sharing, Earth observations, and then we know specifically that there's a lot of overlap among probably most of these. So our categorizations are somewhat fluid, but as you see when you go through the report, we've done the best job we can in order to make the definitions and the categories distinct. Taking us up a little before we delve into what we actually, give some examples of what we actually found when we looked at the information sharing platforms. It's important to come back to the fundamental principle that space sustainability really depends on reduction of mishaps, misperceptions, and mistrust in information sharing. Using globally distributed sensors on Earth, in space, need to all be used so that we have as much information as we can for potential sharing, and then we work out what exactly we want to share, depending on, again, what the challenge is. This is the chart taken from the report. We look at 20 out of around 70 information sharing platforms that we located in our wide research. We restricted the analysis to 20, and each of the 5 categories has a number, as you can see on the left. And the analysis that we did in this chart, take a look over on the right at the top, we categorized within each category whether information, here we are at the top, information sharing formats, were they specified either on the website, in the information sharing platform materials. In other words, do your information sharing according to the specific format? Here's the template, or is it a freestyle situation? And that goes to the point we're going to make at the end about how important it is to standardize the information sharing. So here you have if you go down the list, you can see, and you have the key at the bottom. So obviously the X means formats were not specified, and the V formats were specified. Taking a look at the kinds of participation in sharing platforms, which is a really interesting question, because as we all know, in the past we had space actors were nation states for the most part, for the overwhelming number of space actors. That's changed, and so we have in our key, you can see when whether a given platform shares information among nation states, private sector actors, and whether the public is invited to participate. So if you take an example, let's take a look at the Space Talk, example number 9 down here. You see that the public is also invited to participate. The next column analyzes whether there's a need to register with the platform, or whether there's a specific agreement. This takes us one step ahead. We're going to look at the proposed agreement in the annex to the report. So is there an agreement? Do you need to register, or is it a completely open access platform? And then finally, the actionability of the data. And you can see in the key at the bottom, very short term, immediate, short to medium term, or long term. So that's the way that we analyzed the 20 platforms, and you can take a look into the report into the specific analysis. And this is what it looks like following that chart. So we did a bite-sized summary of each platform with some links, and to make this as accessible to everybody as possible. And then we have this example of how it's really, I think, terrific diagram of Space Isaac, which portrays the Space Isaac members. You can see all the different sort of types of sharing entities, the partner agencies, and what is actually shared. So threats, incidents, and vulnerabilities, and the alerts mechanism. So that's in terms of the methodology, this is how the report was structured, with that one chart and then a drill down into each platform that we reviewed. This is the Wayfinder, the privateer Wayfinder platform that I discussed earlier on. It's an example of, I think, a really compelling example of what a commercial space actor can do when it puts its mind to innovating how information sharing can work. So many of you, or some of you may be familiar with the Wayfinder. I really recommend going in and take a look. It is publicly accessible at the first level. One of the interesting things that we came to at the end of the report, one of the conclusions, is that we see a lot of tiering in information sharing platforms. So what we're seeing on this slide is the public version, and it's a lot of fun to go in and explore. So this is a real time. It's not real time for this moment, but real time as of the preparation of the slide to the space objects. And if clicking on any object will give you, as you can see up on the left, detailing about the object itself. The whole key is on the left, and the legends on the right. So there's a really user-friendly, efficient, incentivized, I think, way to get the information shared about all of the space objects on this particular platform. The innovation that I really wanted to point out here, because the information at the back end or in the back office is common to many of the platforms. It's portrayed, obviously, very, at least to my eye, in a very appealing way here. And at the bottom, we see what's called the crow's nest is here are in at any given point in time to the space object that you have picked out. These are I think it's the 100 closest, other closest space objects in the immediate window of
Deborah,
time.
you have about 5 minutes left, just letting you know.
Thank you so much. And then really quickly, on the bottom left, you see KMI, which is, and here's a real innovation. Here's a company you can click on and say, how much is it going to cost for me to avoid a collision or avoid or take apart my object in a way that's safe. So the privatization piece is referring to another commercial actor offsite that can really help you out with your specific issues. So that's taking information sharing to a whole different level. Our main findings, conclusions, and some ways forward. So I'm not going to, this is, I'm going to read the titles and give a little bit of detail, but you can read on your own. Some of the takeaways, not all of them, are that we are seeing lots and lots of innovation in information sharing facilities for outer space, both, I would say, both in the commercial sector and also in the legacy sector, in the nation state sector, because it's already a competitive market, in quotation marks, and legacy platforms really need to have really understood that they have private sector competitors that are making a lot of sense to commercial space actors. We're getting really good real-time alerts on space-based risks from these commercial actors. The incentives are shifting in a really interesting way, and the report goes into a lot of detail about this shift. So commercialization of space, militarization of space, the commercial platforms are using marketing incentives as they will. And those are incentives that are new, relatively new to the information sharing marketplace. Also, just quickly mentioning that two specific instances of incentivization. So the European Union at present requires information sharing for space activities via regulation, the EU Space Act and then NIS2 regulation. And the White House executive order that came out in December is going in a different direction, at least at present. And in fact, it may entail not only not requiring information sharing across the board, but this new development may entail user fees or other charges for formerly free of charge space information. A bit on the negative side, or a bit on the work to do side, let's put it that way. So current data formatting efforts on information sharing platforms are still fragmented, and they hamper scalability, which I referred to in the first slide. And finally, we have hidden actors. So this is a whole other research report, which would be interesting. Of course, military and national security actors don't readily share information. So they have a lot of information that would be great to have on commercial platforms or more public platforms, and they don't share that information. And also very interesting that space insurers have a lot of information that's not shared. Quickly looking at the model information sharing agreement, the structure and the guiding principles, it's fairly intuitive, but I think really important that we put our minds to thinking about how to get this done best. The example that I wanted to share, go over this in your eyes really quickly. Nothing here will surprise anybody, but it's all in one place. And I think that's some of the value that we tried to bring in this report. There's got to be transparency. There's got to be an understanding ahead of time of what we're sharing and who's getting the information that I'm sharing as a private space actor or as a public space actor. The EU Space Act does this really well in their terms of reference. I'm going to wrap again with this slide. We really are aiming with all of the 20 platforms that we reviewed, we're looking at carefully at how each of those platforms build a trusted information sharing mechanism and have detailed and analyzed as much as we could how that happens. And I think that's really the end goal. Our bottom lines we've already looked at, so I'll refresh memory, and I want to add something as I conclude. What was I think the biggest challenge of the research undertaken, which was a steep learning curve and an interesting learning curve, is that we have less information as researchers on how the platforms are actually, in fact, used by space actors. So many information sharing platforms have done their best to set up the platforms, to bring in as many users as possible, to incentivize them, and kudos to them. There's a lot of work to be done, and I think one of the important steps that need to be undertaken as we move ahead is to really look at how, in fact, what's the de facto situation? How much are space actors on a day-to-day basis using these some very sophisticated information sharing platforms? And I'll wrap with that.
Thank you for your well thought out presentation, Deborah. Really enjoyed it. Now we will transition to our question and answer session moderated by Dr. Martinez. Please continue to submit your questions in the chat. Please begin, Dr. Martinez.
Thanks, Kathleen, and thank you, Deborah, for your very interesting report and presentation. And this is, of course, a very timely topic. Just this last couple of weeks at UN Corpus, a newly established expert group on SSA information sharing began its deliberations, and I'm sure that work like this will be valuable food for thought for the delegates involved in those discussions. So perhaps just to kick off the questions, what would you say is unique or different about information sharing in the space domain as opposed to other domains on Earth, such as aviation or maritime? And what lessons can we take from information and sharing experiences in those domains, which also, of course, have aspects of sensitivity, security, and so on, as you mentioned, for space?
Sure. Thanks for that question. So space is different because let's do the commonalities. The commonalities are defined by really that the issue of a problem that needs to be solved by a multitude of actors, a multiplicity of actors who are very, very different in their interests and in their resources, but with the same risk mitigation problem. So we see that, for example, in the World Health Organization, we see that in maritime, we see that in the Antarctica Treaty. How do we mitigate the risk in all of these environments that are very risk heavy? What's special about space, and the reason that information sharing in space is so critical, is I'm going to circle back to one of my first points, is that the hostility of the space environment, which makes it differently risk heavy than terrestrial environments. It's much harder for us as humans, and even the machines among us, it's much harder for us to get a real-time apprehension of what the risks in outer space are. And also we need to, largely at present in any event, we need to take care of them through cyberspace. Again, we have a limited ability to take care of space risks physically in space, and yet a lot of the risk mitigation needs to take place through cyberspace, and that has its own risks and its own difficulties. So that's the short version about why I think the use of information sharing in space is different. But I would end by saying there's a lot that we can learn about information sharing from other mechanisms that have been tried and true. Again, the ones that were mentioned earlier.
Thank you. And I see that we have lots of interesting comments in the chat and a number of questions as well. So I'll move to an audience question. Maybe it's more of a statement, really. And it's about the registration of space objects with the UN, and the comment being that most countries eventually register their space objects. And the question was, is it reasonable to assume that today's operational databases, such as SpaceTrack, EUSST, and others, are more accurate than the registry, a more accurate registry of objects on orbit than the official register?
I'll say two things about that. First of all, broad praise for the register. I think I'm an international lawyer by training, and it's a phenomenal instance of the international community addressing at a very early stage of activity the need to register space activities, space objects. I think I even wrote this down so that I would be able to remember it. Didn't know the question was coming, but the Article 11 registrations start. I actually went in and checked. And by the way, got a lot of help from Dr. Francisca Noor from the legal subcommittee Peter, that you referred to. So the earliest registration that in the UN registry is from 1967. The US notified regarding Surveyor 5. So 1967. That's a legacy registry. So I think high praise for that. On the other hand, I don't have the number in my head, but the number of states who have joined the registration treaty is not equivalent to the number of states who have signed the OST. And there's a gap there, number one. And number two, remember, it's a feasibility registration. So if it works out, register. If you find a reason as a country not to register, and this is certainly true for military registrations, then there's no sanction for not registering. So bottom line, one of the I think important tasks that awaits us as researchers is to answer the question of what are the differences between the legacy registries and the new commercial registries. And I want to tack on one of the interesting problems that we're going to have with the commercial, we already have with the commercial registries, is that their registries are proprietary, and their commercial IP. I don't know about any legal contestation around that yet, but get ready. I think it's going to be a really interesting issue. If I have a private, commercially funded and operated satellite catalog, I can give access to it to those people or those companies or those entities that I choose to allow access. So that's an open question right now. But taking the question a little bit farther, but I hope that answers what you've asked.
Yeah. Well, thank you. Actually, your answer kind of led in very nicely into one of the audience questions, which was, keeping this track of the information sharing by the commercial operators. How do you persuade companies to share commercially sensitive information?
Oh, it's hard. It's hard. The easiest way to do it, and we can have a fist fight about this if anybody wants to. The easiest way is regulation, the way that the EU does it. So the EU Space Act, which hasn't yet come into force but will soon, and the Network and Information Sharing Directive, it requires space operators, not all of them, but a nice section of them, nice tranche, requires information sharing. That's the easy way to go, whether you're a commercial operator or not. As we know, the United States has a more liberalized system and does not require information sharing. So that the bottom line answer to that question is it's a three-part answer: incentivization, incentivization, incentivization. Make it worth their while. It's a marketing. Apologies for making it that commercial, but it's really about if we don't have a regulatory requirement, it's really about making it worth a commercial actor's while to join into an information system. Do you want your satellite to head into orbital debris without any information about what's liable to hit you? Go for it. That's your risk. Convince that commercial operator that it's in his or her interest to act differently.
Right. And staying on this theme, but broadening it a bit to think about the security dimensions. Of course, commercial operators operate under national regulatory regimes, which are subject to national security concerns. And so to what extent can these national security considerations be a factor in information sharing by these commercial entities?
So if I've understood the the question correctly, please let me know if I haven't. The national security considerations are obviously, again, they can be conveyed through regulation, as they are in the United States as well, that commercial actors are subject to as well. So it's going to have to be a real-time look at, what are my regulatory constraints as a space actor? What is my license? Open your license. What does your license say? And to what regulatory restrictions are you subject? If you're a defense contractor, obviously that's going to look much more rigorous and thorough than if you're LEO satellite operator that's operating privately for the first time. I say so. Obviously, it depends on which country. So there's clearly an interaction, and that's going to be an interesting conundrum, because on the one hand, I'm saying this for the first time in the same sentence, whereas on the one hand, a commercial actor may be constrained and not permitted to share information because of security constraints. On the other hand, the security entity to which the company may be subject may be sharing that information in a different way through a different information sharing system. And we have no way of knowing that because it's not transparent. So, and again, coming back to the whole issue, and with this is the way I would summarize it is, those national security actors share information with one another, also internationally, clearly, because that sharing is not transparent and can't be transparent. I'm not arguing that it should be necessarily, but they may have incorporated already into their information sharing the commercial information that was referred to that had been blocked from sharing by the commercial operator. I hope that makes sense.
Thank you. So let's pivot now to what you might describe as part of the sort of the mechanics of effective information sharing. And as we all know, there are many different sources of information, different formats, standards, etc. So what standardizations are there that are being used internationally for information sharing, and how can standardization be advanced through diplomatic and other means so that we have a well-adopted, well-developed international system of standards for space information sharing?
Question of the year. It's a key issue. And again, it goes back to that point of a system of systems, the interoperability of information sharing systems. I'm a real believer in standardization. I've done, in preparation of the report, had several discussions with standardization experts who shared a lot of information about how dynamic the development of space standards is right now. So a lot of really important work is being done. I don't want to specify. I'm going to specify one, which is less of a standardization, but more of a format issue in a second. It's very much a dynamic development. The issue isn't, the people who write standards are really smart and really understand space and really understand data exchange in space. The issue is less which particular standards are being developed, although again, I'll refer to one in a moment, but their adoption. How do we compel their adoption? How do we get them into play? Do we do it one easy way to do it, or more acceptable, more sort of harmonious way to do it is through defense contracts, for example, through sort of get the national security folks on board first, and then work really hard on the commercial actors. But some commercial actors, on the other hand, are developing their own standards, which aren't compatible with legacy national security standards. The one example that I wanted to give, because there's a long list of space standards, and I'm happy to take that offline and give specifics. A lot of good work is being done. But Peter, as you referred to the COPOS working group that has started its work, they have specifically begun work on this report out, or a paper out from last May, called the First Ideas document, which is referenced in the report, on an Article 11 template, modernized, brought up to speed with space activities of today. That's in process right now. I think that's a really important standardization in the widest sense, getting a template in process under Article 11, and that will have a really wide, I believe, a really wide adoption rate once it's in play.
Thank you.
But if you want a specific list of standards, if you want it, we can take that offline if you'd like. Happy to do that.
Thank you. Yes, I think this Article 11 conversation is a very interesting and timely development. So to close, I just want to end with one question. We're up against time, but I want to sneak this one in, and perhaps if you could just very briefly respond to it. So I want to continue on this thread of interoperability in the system of systems, and we will need to collectively evolve from the limited information sharing that we have today to a more comprehensive, more routine way of sharing information. And this will probably involve some incremental and possibly tiered approach to sharing more information critical for spaceflight safety and building trust over time. Do you have a view of the sequence of steps that might be necessary for this evolution in information sharing?
Yes, and those steps are proposed at the end of the report. Again, all this is stemming from the research. First of all, it's really important, and I see that some of the audience members have mentioned this in the comments on the side. It's really important to have a convener, either COPUOS or another organization, a convener to have this conversation in a really broad context. Private sector actors, nation state actors, even individuals who eventually will become actors in space and will need to share their information. And to start a conversation about how we want to think about standardizing data formats, how we want to think about standardizing processes of information sharing. Again, that would be step one. Step two is a really comprehensive look at how information is shared, is best shared. Where do we have the most, I'll use the phrase buy-in, where do we have the most buy-in for information sharing? On all of the platforms, those reviewed, those that haven't been reviewed, and why does it work? What works well about that? How is the trust established among the sharers? And how do we take out of that, how do we extract from those successes what we might want to include in our discussions? And then the third step, which is again at the end of the report, you'll see in the annex, I think that the transparency piece really needs to be expressed in a standard information sharing document memorandum. There are enough common principles to make it a standardized agreement, which can obviously be taken in its annexes to a particular context, the lunar context, for example. But first, let's get everybody on board with what the priorities are, what the incentivization looks like, and then look at a common document that can put everyone literally on the same page as information sharing becomes really that system of systems that we're aiming for.
Great. Thank you. Yes, and I see that this is at the end of your report, and I would encourage all of the participants in the webinar to download the report and read through it. It's very, very interesting indeed, and very timely. So thank you very much, Deborah, for your presentation and for the questions. Thank you also to the participants for the interesting questions. With that, I will hand over back to Kathleen.
Thank you so much, Deborah and Dr. Martinez. And thank you all for joining us today for the 2025 Space Sustainability Research Fellows Report webinar. We are especially grateful to our outstanding fellows for their time, rigor, and thoughtfulness each brought to their research and presentations. Their work represents an important contribution to advancing practical solutions for long-term space sustainability. I would also like to extend sincere gratitude to Peter Martinez, Ian Christensen, Chris Johnson, Damaris Thomas, Robert Pemberton, and everyone at Secure World Foundation who supported this project and helped make today's event possible. A recording of today's webinar will be shared with anyone who registered via StreamYard. We also encourage you to explore Secure World Foundation's other resources, including our annual Counterspace Capabilities Report, the Handbook for New Actors in Space, and the COPUOS Briefing Book. all of which are designed to support informed, responsible space activities. Additionally, we hope to see many of you at the 8th Summit for Space Sustainability, which will be held in Brasilia, Brazil on November 4th and 5th, 2026. Here we will continue these critical conversations on the future of the space environment. Thank you again for being part of this important discussion, and we look forward to staying engaged with you.